Alright, time for another math easy solution. Here to discuss transformation of functions and look at part one of this series. We're going to do vertical and horizontal shifts. This is very important, I find. And part two will be on basically stretching of functions and whatnot. So I'll start by basically I'll just draw a giant XY plane. There's the x-axis. Just make that a bit better. Yeah, so basically there's XY plane, this is Y, this is X. So basically if we have a random function like this, we'll just call this a random function. So we'll call this f of x. Okay, so basically what this, so that's f of x. Let's say we want to graph something like, well, we could even, I'll just write it down here. Let's say we want to graph y1 equals f of x plus a, and where a is just greater than 0, and that's just a random number. So what this means is that at every point on f of x we just shift up. If let's say this is f of 0, so then this would be f of 0 plus a, so all we're doing is shifting up a. So let's say a is something like this, from here to here is a. And then if this is f of negative something, whatever, then you would just shift again. You'd shift a. So that's all it is. All it is a shift up. So then this, if you were to graph it all, it would just be exactly like that, except this is, shifting up. So then we'll call this is shift up. So that's all it is. We're shifting up. And this would just be y1 equals fx plus a. X plus a. So let's look at another one. Let's y2. This one's fx minus a. Now this is exactly the same as this, except now at every point you would minus a. F of 0 is this, then is f of 0 minus a. So we're just gonna go down minus a. So this would be here. This would be minus a. All the way here. So then in this one, just going to shift all the way down again. So basically it's exact same except we're shifting down. Then this would just be y2 equals f of x minus a. So we got this one. And this one is just shift down. This is pretty basic. Shift down. So now we're going to let's look at something else. Let's look at, let's say we had y3, or even I'll just write it even up here. So let's say we have now equals f of x plus a. So now we're inside the brackets. So what this means is, let's say if we have something like, let's write it down here. Let's say if we have, or even shift it down here. Let's say we have f of 0. This is f of 0. So we know that's f of 0. So let's try to get f of 0 from y equals 3. So f of 0 in y equals 3 equation. To get f of 0, we just have to make, well, basically x plus a equals to 0, and then x equals to negative a. Just solve it. So that's what it means. So basically at x equals negative a, we get f of 0. So that's basically f of negative a plus a equals f of 0. So basically that's when x is equal to. So here we're shifting negative a. So here's this is 0. So to get this one, we're shifting actually, we're shifting all the way here, which is negative a. So we do that for every single part here actually. So now all this is a shift to the left. And then this would just be f of 3. y3 is x plus a. So then this one is a shift left. And then if we have, let's say y4 equals f of x minus a. So this is similar to this one. We just make x minus a equals 0, and then x equals a. So then this means that at f of a minus a, we get f of 0. So basically at f of 0 is here, this is for f of x, but then to get that we need to shift a all the way to here. So then we shift plus a. and then we get something like this. We do that for every single part of there. So then we get a shift to the right. This is why 4 equals f of x minus a. And then this one is shift right. Okay, so yeah, that's basically the shifting at vertical and horizontal shifts. We'll do an example here. Let's look at. Let's say f of x is equal to x squared. So, and then this one would look like this. So this one just looks like this. That's basically f of, yeah, this is just a parabola. And this is y, this is x. It's a bit off, but yeah, then this is x squared. Let's say we want to graph, basically let's say we want to graph f of x, let's say plus 2. So in this one, all we're doing here is just shifting. So let's say this equals y2 or whatever. So again, like before, this is f of x, f of 0 is 0, so we shift 2. F of 1, this is, let's say, 1 squared is 1. So 1 squared equals 1. So we go here, but then it goes to 3. So this is 3. So that's 3, then it's basically going to be like this. And similarly for this, this would be x squared plus 2. This equals to x squared plus 2. And then this one would just be down here. And then, and if we were to do a negative one, it would just be shifting it downwards like this. So it would be something like this. And this would just be x squared minus 2. So let's say we want to graph, actually let's go f of x plus 2 inside. So then all we do is put it inside the f of x. So we know f of x is x squared, so then we're going to get, so inside the x becomes x, it becomes x plus 2. So we'll have x plus 2 squared. And like before, this is just a shift. This is a shift left. And then we'll just go 1, 2. So we'll just draw it here. We'll draw this one. This will just be a rough outline of it. So that we have, this is x squared. This is y. This is x. So basically here, this one, we're just going to be going left 2. So we go 0. This is 0. This is 1, 2. So it's going to be something like this. And this is, x plus 2 squared. And similarly, if we go the other ways, it's going to be like this. And this is x minus 2 squared. So just remember that negative is actually shifting to the right, positive is actually shifting to the left. Because you got to make it equal to 0. To make this equal to 0, you put a negative 2. And now this one you put a positive 2. So that's one. And let's just get let's go a hard example here. Let's go graph this one. Let's say graph x3 squared plus 16. So now we know that if you look at the basic one, we know that this is a transformation of x squared. This is a transformation of x squared. That's all we're doing is just putting in. This one, all we're doing here is just actually, if f of x equals to x squared, then this function is just, we'll call this, let's say, this would just be f of x minus 3 plus 16. So that's all we're doing is shifting this function. So if we were to graph this one, it's very easy. It looks complicated, but it's very easy. So you just go like this. So you shift 16 up. So we go shift all the way up, and so this is, so we shift all the way up. This is, say this is 16. This is y. And this is x. And then this is negative, so we go to the right. We shift right 3. So we shift, let's call this 3. So we go up and then we go right, and then it's going to be a parabola. So there you go. This is very easy. And this is just x minus 3 squared plus 16. So basically, whenever you're graphing something, you just quickly in your mind, remember to, just as a hint, yeah, it might be. Just look at the basic function. Look for, let's say, yeah, basic. Yeah, basic function inside the complicated one. So in this example, it's just x squared, because it's probably, yeah, and it's x squared, and it was just a transformation of it. And then, yeah, that other stuff was just a transformation. Just a transformation. Yeah, so basically, if you understand this transformation of all the functions, you can graph like many other ways, and then all you got to know is just the basic one, and just how to shift it, how to whatnot. I'll show you the stretching of them later in my part 2 series. Well, thanks for watching. Hopefully you learned, and this is basically if it's plus a shift up, minus a shift down. If it's inside, plus and minus are actually opposite. Plus is left, minus is right. So that's all it is, and then you could use that basically to find out what your basic function is. In this case, it's just x squared. These are all just transformations of it, and then you could graph it easily. Well, thanks for watching, and stay tuned for another Math Easy solution.